Hi, I've been real busy the last couple of weeks and I have tons of new stuff to show you. So what started out as a Hexapod simulation tool that I made for my own sake, since I couldn't easily wrap my head around the math required for making this thing move. As I had new and more features, it's slowly evolving into something more like a Hexapod design studio. I've loosened some of the concepts up a bit. In previous versions, the robot legs had to be uniformly spaced around the robot body. That's no longer necessary. You can position or anchor the coxas or the legs at any point on the robot body. There can be different angles, and leg segments no longer have to be the same for all legs. So let's say you want to make a spider-like robot where the front and hind legs are longer than the legs in between, and the leg segments differ between the legs. That's now possible. You can, as long as the robot is stable with the legs in the stance phase, those are the legs that touch the ground, your robot can look like anything you want. It's also now servo type agnostic. I'm normalizing everything, so it doesn't really care if your servos have a kind of maximum 180 degree rotation or 300 degree rotation. It's all normalized to a standard format. And it doesn't care if you follow the right-hand rule, if you accidentally build your robot so that the servo horn is pointing the wrong way in reference to the reference frame. I've added bit masks that indicates that the servo is flipped, so the math will still work. I also added new concepts like motion primitives, where you can record, let's say, a single step or a series of steps, single moves or a series of moves as files. And those files are quite small. And you can store those files on an embedded file system, like, for example, SPIFs. And the benefit of that is that the robot controller can control servo timing. If you just bombard it with a stream of parameters from a simulator, it will need to buffer data if it wants to control timing or speed. So now you have the option of doing both. You can either stream parameters or you can record motion primitives. So let's go through the new features one by one. Okay, let's build a new hexapod and make it a bit more interesting than this one. We can start with, we can use one of the built-in samples as a starting point. This one. Let's say I want to change some leg segments. I'll change the tibia lengths for segment lengths for leg 1 and 2. So I'll say set tibia length 1 to 200. And now you can see the legs segment has been extended, and I'll repeat the same for the other leg, like so. And let's change the kind of anchor or angles, or the coxa angles for leg 4 and 5. So I'll say set coxa angle 4 minus 20 degrees, and I'll repeat the same for leg number 5, positive 20 degrees. And as you can see, now the end effectors are not intersecting in the same plane, and that's a problem. So I've added a new command that can anchor the end effectors. So I call that command ground, and here we can specify the z height, or the spacing between the end effector and the coxa in the z-axis. So let's say 50. Now we have all the end effectors in the same plane. And now I can save this. So so I'll save it. I call it demo bod. We can take a look at that file later on. Next is to see if we can make this thing move. So I'll define a walking cycle for it. Stride vector, and the first argument is the number of cycles I want it to go through. So let's say 5 cycles. If I specify 0 here, it will repeat until I stop it. So since this is a vector, I want no deflection on the x-axis, and let's say 30 on the y-axis. Now we have a defined walking pattern, and let's specify speed as well, maximum, and we can start. And now it should run through 5 cycles and then stop. And let's say I want to record and make a motion primitive. I can switch on recording, record on, and now I can single step. So I'll perform one step. And now I can export that last step to a file, and since the stop and start positions on the end effectors is the same, the microcontroller can just cycle through this. If it wants to move a longer distance, it will just repeat this motion primitive. So let's say export and give the primitive a name. Let's call it forward 30. Next is the maximum range of the servos. Some servos may only be able to rotate like maybe 180 degrees. Others maybe 300, so I'll specify the maximum rotation angle of the servo. In this case it's 300 degrees. Next up is a bit mask that indicates if you have flipped the servo upside down. The servo horn should also always be pointing in the positive C direction of the local reference frame. If it's inverted, like in this case, I'll specify a 1 for inverted coxa, not the inverted femur, and not inverted tibia. And now we can see that it has exported the primitive to a file called forward 30, and the angles are normalized. So the exported range is from 0 to 1024. The value 0 is the same as minimum angle for the servo, and 1024 is the maximum angle, and 512 is the midpoint. So 512 is 0 degrees, 0 is negative 150, and 1024 is positive 150 degrees. Yeah, we switch off recording. Record off. We can take a look at a couple of other examples of hexapods that you can make now. This is a really simple one. Made a preset for it. Preset 1, sorry, 0. This is a rectangular hexapod where you have 3 legs on one side and 3 legs on the other. Let's define a walking cycle for it. Just make it repeat indefinitely. Yeah, let's say 10, 20. So it's a bit tilted. Speed 10, start. So here you can see you can make hexapods of various sizes and shapes. You can stop this, and I'll show you another one. I started tinkering with spider-like creature. It looks like a bit of a mess right now, but it illustrates the point of having significantly longer hind and front legs and short legs in between those. We can see if we can make it spin. So we'll say strides angle and just repeat indefinitely. Let's say 50 degrees. And here you can see you have different arcs for the longer limbs and for the shorter limbs. We can run it. Start. I confused myself. So in time I'll probably build one of these and try to make it look as much like a kind of normal spider as I can. Yeah, it's currently using a tripod gait. You can see the on the bottom left quadrant that it's the same pattern as if you have 6 legs. It's just got more of them. We can stop this. Yeah, I also started tinkering with shifting the coxas. Let's start another one. Where is it? This is still in progress, but I want to make or enable it to make moves like pitch and yaw and roll, etc. So I started with a simple kind of translation up and down to modify the ride height. So I'll say down 10 and it shifts the entire thing down. And there is no kind of error checking here, so I don't check to see if it's actually a valid solution. It was just kind of a proof of concept to see if I was moving in the right direction or not. So let's try that one. Down 30 minus 16. So here you can see it lacks verification because it will kind of stretch the leg segments. Minus 100. So, but that will be fixed in the next version. So why motion primitives? Well, I tried speeding up my bot using streaming, where I basically bombarded it with packets faster than it could swallow them. And the result was kind of funny and a good illustrations on what happens if the bot can't buffer up packets and control its own speed. So it looks like something between a kind of child's tantrum and the results of a denial of service attack. Yeah, you probably noticed this clicking noise that increased towards the end of the previous segment. That noise got old really quickly, so I decided to make some shoes, shall we say, for the end effectors. These are cast in really smooth rubber, so I used Dragon Skin 10. That reduces the noise, and it also prevents the hexapod from sliding around on my desktop.
you get the nerve to try and break free of me? I would hope that you know better than to bust our bonds. You know we are a rarity. So easy to prepare, but too hard to escape. Better not to get bent out of shape. Now cover up your eyes, now spell it out slowly. All of the things that you've done wrong. You're dirty and I like that.
So what's next? I still have bugs in the system and I need to iron those out. I'm also going to try to do some PID tuning of the servos. From the factory, these only come with a proportional parameter set, and that makes a difference. If you're running the servo kind of without a load or not installed in the framework, it will behave differently than when it's installed in the robot. So I'll try to do some tuning and see if that makes a difference. I also have more transformation matrices to battle with. So when this robot is walking, I'm solving the inverse kinematics equations for the end effectors. If it's going to do stuff like pitch and yaw and roll, I need to solve the reverse of these equations. Well, not exactly reverse, but then the end effectors will be fixed in place, and we're on the same, basically the same equations, but we try to find the joints after having transformed the coxa plane in rotated or displaced in X, Y, Z. So that's the kind of major thing that hasn't been implemented yet. I'll experiment with the number of interpolation steps and see if I can make it walk any faster. It's a bit slow, so we'll see if I can do something with that. I also have a ton of Dynamixel MX12W servos. I ordered 18 of them by mistake. They're incredibly fast servos. They don't have much torque, but I might be able to make a fast hexapod with it as long as I keep the segments pretty short. So I haven't designed anything yet, but that's an option. I also have my old big hexapod that's using the AX12 servos. That's on the to-do list as well. So there's still plenty to do. If you liked the video, please subscribe. Okay, until next time, bye.